Let's look at our last solution, which is on condition-based monitoring systems. Again, in the context of COVID, this is important because it enables companies, managers, shop floor supervisors to keep a track of the machine performance, to keep a track of what are the issues, what is causing failures, and most importantly, what can potentially cause failures, and be able to red flag that even before the machine failure occurs. The way the solution is set up is through a simple system of sensors going through an advanced analytics algorithm that are then able to predict a percentage chances of failure for a particular equipment depending on the running conditions. If the temperature, vibration, sound, etc. become too high, then it can raise an alarm and enable preventive maintenance rather than breakdown maintenance. So let's look at the solution now.
Let me introduce another solutions, another use case that we implement in the DCCs. It's called the condition monitoring. So at the right-hand side is the NTS 1000 CNC machines, which we use to manufacture or process the gear and the bearings to be used at the assembly line. So what we are doing here is to implement a condition monitoring systems to monitor the condition of the machines. So from our studies, we noticed that the CNC machines, there are main 5 components that are causing most of the defect. The bearings, the ball screw, the slide, the servo motor, and controllers. And each of these components have different defect characteristics. And when we study, we do a deep dive study to understand the defect characteristics and the defect rate. We notice that the ball screw are causing most of the defect. That's why in these examples, we install vibration sensors to track the condition of the ball screws to make sure it's fall within a good operating threshold. So the thing is, when the ball screws are used frequently, it will causing wear and tear, and this wear and tear will also causing the vibration amplitude to either surge up or go down. So we have installed 6 vibration sensors across 3 axes of these ball screwdrivers, and from the historical data, we're able to know what are the upper threshold and lower threshold that this vibration sensor can go. And from here, we're able to know whether the ball screw are in a good condition when they are operating. So when the blue axis here actually showing the amplitude of each of the vibration sensors. So once the amplitudes are cross a certain threshold, then it will indicate that there's a abnormal ball screw vibration here. And from here, it will also alert another work orders to our maintenance workers that what should be done to calibrate the ball screwdriver so it will fall back to the normal operations. So the companies that will benefit for this kind of solution normally is a more advanced companies. So for those companies that do not have a good ROIs, then normally we will install a CAP base to extract the sensors data directly and do analysis from there.